Welcome back. In this session, we are going to take it easy and chill. We are going to create an enemy prefab, and that's it. So let's get right into it. First off, open the crowd runners folder, then the prefabs folder. Okay, select the runner and hit Ctrl D to duplicate it. Perfect. Let's rename this guy to enemy. Okay, I couldn't type. Perfect. Then let's double click on it to open it. All right, we can diminish this and select the body. Now we are going to create a new material for our enemy. So select the runner material here and duplicate it by hitting Ctrl D. Same thing, we can rename it enemy. Perfect. Come on. And we can also change its color to something reddish. Okay, same thing for the emission. Perfect. Let's close this window now. Select the body of the enemy and drag and drop the enemy material into it. Perfect. We've now created our enemy prefab. Let's just quickly create a new script for this enemy. So open the scripts folder, right click, create C# script, and let's call it enemy. Perfect. Now select the enemy. While you're still in prefab mode, drag and drop the enemy script onto the enemy inspector. And voila, we've got our enemy prefab ready for configuration. In the next session, let's see how we can implement this enemy class to work in our game. So see you there. Welcome back, guys. So after creating our enemy prefab, let's now implement the enemy class. So double click on it and let's jump right into it. Okay, first things first. We are gonna make a state machine for our enemy because the enemy will have two main states. Maybe three, but we are gonna use only two for now to keep things simple. The first state for the enemy will be the idle state. It's the state he's just standing and waiting for a runner. The second state will be the running state, in which the enemy is running towards its target. So let's do that. First, we want to create a new enum called state, and this will have two options, the idle state and the running state. Okay, perfect. Then we want to create a new header for our settings. The settings category will have some variables, like for instance, a field for our search radius. So this will help us determine how far the enemy will be able to search for any runner. Then, when he's found a runner, we can add a new variable for the move speed. All right, perfect. After that, let's create a variable for our state. So let's just call it state. And finally, we want a new variable for our target. Or maybe let's call it target runner. Perfect. So, in the update method, what do we want to do? Let's call a new method in here and call it manage state. Perfect. Let's create it. Private void manage state. As we did before, we are going to use a switch statement right here. So depending on the state of the enemy, what do we want to do? In case the state is equals to idle, we ideally want to search for a target. Then we can break. All right, perfect. And the next case will be the case in which the state is the running state. So the case when the enemy is running towards the runner, we can just say run towards target. Perfect, and break. All right, let's now create these two methods. So private void search for target. Okay, perfect. And the second one will be a private void method to run towards target. Okay, perfect. Let's just create a method to switch from the idle state to the running state. So let's call it start running towards target. Okay, perfect. We now have our three main methods. Let's now implement the search for target method. So we are going to search for any runner nearby. So let's create a new array of colliders. let's call it detected colliders, equals physics. We are again going to use the physics class, dot overlap sphere, to use the overlap sphere method. So this will create a sphere basically around any position again, and we want to specify a radius next. So let's create a sphere around the enemy, so from the enemy position, and the radius will be our search radius. Perfect. Now we are going to loop through all the detected colliders, so from 0 to detected colliders.length, and we are going to try and find a runner. So for that, we can add a condition. If the current detected collider has, so we're going to try and get some component, has a runner component, okay, has a runner component. We haven't created this runner component yet, but we are going to do so right in the next session. Anyway, if the detected collider has a runner component, what do we want to do? First off, we want to check if the runner we've found is a valid target. If it has already been targeted by another enemy, we can just pass and search for another runner. So if the runner is target, if it's already a target of another enemy, we can just continue. So go to the next index. Otherwise, it's not a target. So let's set this runner as a target. So let's call a method that we are going to create later, runner.setTarget. Okay. We also want to specify that our target runner, so the private field, the private transform that we've created here, is equals to this runner. So just in order to store it, to be able to follow it or run towards it later on. After doing that, we can start running towards our target. Perfect. In this method, we are just going to say something quick, which is state equals state.running. It's just to change the state of the enemy. This will allow us to switch from this case to this case. Okay? So now the run towards target method will be called inside the manage state method. Okay, so let's implement this one. So first thing here, we want to check if the target runner equals null or not. If it's equals to null, we can just return. It's just a precaution here because we have normally found a runner in the search for target method. But anyway, next we want to modify the position of the enemy. So it's going to be transform that position equals, and there's a cool method in the vector3 class to move our enemy as we wish. It's called move towards, and it returns a vector3. So we are going to move towards our current position, which is the position of the enemy, transform that position. The target is the position of the target runner, so target runner.position. And the max distance delta will be dependent on the FPS of the device. So it's going to be time.delta time times our move speed. Perfect. Then while moving towards the runner, we want to check if we are close to it or not. If we are too close to it, we want to destroy both the runner and the enemy. So if the distance, and again we are using a method inside the vector3 class, which is called distance. It takes two vector3s as arguments. So the first one will be the position of the enemy, and the next argument will be the position of the target runner. Okay, so now that we have the distance between these two transforms, let's check if it's less than 0.1f, let's say. That's a certain threshold. So when the distance will be less than 0.1, this code will be executed. Okay, so what do we want to do in this code? We can just say destroy the runner, so target runner.gameObject, and we also want to destroy this gameObject. So now we are destroying the runner and the enemy. And I think we're pretty much done, but the only thing we forgot here is when we start running, we need to remember that the animator of the enemy is by default playing the idle animation. So we just want to grab the component, the animator component, so animator, and we want to play the run animation. And this completes the script for our enemy. Perfect. Okay, cool. So now it seems that we've got an error in the enemy script, and this is normal because we haven't created our runner class yet. But this is exactly what we are going to do in the next session. So see you there. Welcome back. In this lesson, we are going to create the runner script and attach it to the runner. And we also are going to do all the necessary things to make the runner attack the enemy or vice versa. So the enemy will also attack the runner. Okay, let's jump right into it. For that, we are going to open the scripts folder and create a new script called runner. Perfect. Next, before attaching it to the runner, we need to create this isTarget method and all the other methods that we've specified in the enemy class. Okay, so let's just press Ctrl and click on runner here to open the runner class. Then we want to create an isTarget method. So let's double click it, copy it, go to the runner class and paste it public Boolean. It's going to return a Boolean just to know if the runner has a target or not. And here we can create a new Boolean. So before that, let's create a header for our settings. Let's create a new private Boolean isTarget. Okay. Here we just want to return isTarget. Perfect. Next, we need to add the other method that we called from the enemy class, which was public void setTarget. Okay, this will only be responsible for setting the isTarget Boolean to true. Perfect. So now let's go back to Unity and we shouldn't have any error. So let's clear this. And we do have an error here. So let's double click it. Oh, I see. Here the target runner is a transform and we want to assign a runner class to it. So let's just say runner.transform instead. Okay, we don't have any errors. So now we can go to our prefabs folder, select the runner, go down here in the inspector and add a new component. This component will be the runner component. Cool. We now have the runner script attached to our runner. So let's add a collider to it because if you remember, in the enemy class, when searching for a target, we are calling the physics class and we are storing this data in a collider array. So that means that if our runner doesn't have a collider, the enemy won't be able to detect it. So we need to create a collider for our runner here. Let's open it. Double click on it. Perfect. Here we have it. Let's add a new component and we are going to add a capsule collider to the runner. Let's hit enter. Perfect. So here we can't see the capsule collider because the scale of the runner is 0.01. So what we can do here is increase the height like so. And now you can see that there is a green outline that's being created. We can also increase the radius like so. Perfect. Now we can also increase the height and the Y position of the center. Okay. Because we won't be using the collider for other stuff, we can keep it as is. Okay, cool. Now, let's just drop an enemy in the scene to check if everything we've done so far is working. So drag the enemy from the project window to the hierarchy window. Okay, let's move it on the Z-axis like so, and maybe rotate it by 180 degrees. Perfect. Now we can increase the search radius of the enemy. So let's say 5 for now, 5 units, and the move speed will be something around 10. Okay, let's save the scene and hit play. So for now, the enemy isn't moving, and that's great. So let's hit play and see what happens. Cool. Have you seen it? The enemy ran into a runner and destroyed it. Let's play that again. Or maybe let's duplicate the enemy a bunch of times. So select the enemy, press F, then move it a little bit and Control D, press Control D again and Control D again, and so on, as many times as you wish. So I'm just going to place 6 enemies for now and hit play. So initially we have 12 runners. We should have 6 runners after they fight. So let's hit play. And perfect, we have 6 runners. Cool. The logic is now working. So in the next session, we will see how we can create groups of enemies procedurally and add them to some specific chunks to make prefabs out of them. That way, we will be able to create more and more levels. See you there. All right. In this session, we are going to see how we can create a group of enemies, make a prefab out of this, and use it in a chunk. So we can remove our enemies for now. Let's create a new game object. It's going to be an empty game object and call it enemy group. All right, perfect. Let's press F to focus it in the scene. Then we want to create a new script. Okay, so let's go to the scripts folder and create a new script called enemy group. Perfect. You can drag this script and drop it into our freshly made game object, enemy group. All right, let's open this script. So the first thing we want in this script is to have a reference to our enemy prefab. So let's create a new header for our elements. Let's create a field for the enemy prefab. It's going to be an enemy prefab. Okay, perfect. Next, we want a settings header. So let's create it. Perfect. This category will hold some data or some settings, like let's say it's going to be an integer, which is going to be the amount of enemies we want for this group. So enemy amount, or let's just call it amount. Perfect. Then we want to create our enemies. So let's create a method for that. It's going to be a private void method, and let's call it create or generate maybe enemies. Perfect. We will call this method from the start method, just for the enemies to be created at start whenever we start a level. Okay. And when creating the enemies, we are going to create them and set their position using the Fermat spiral that we've used for the crowd. To do so, just go to the crowd system class and grab our Fermat spiral and get the getRunner local position method, like so. Just copy it, go to the enemy group class and paste it. But we need to specify the radius of the spiral along with the angle. So let's grab this data from here too. Let's just copy these 2 fields and pass them in our enemy group class right here. Perfect. Now we can create a for loop in the generate enemies method, like so. And we are going to loop from 0 to the amount of enemies we want. We are going to create a new vector 3 that will hold the position of the enemy. Let's call it enemy position, or maybe enemy local position. Okay, cool. It's going to be equals to get runner local position with the index I. Perfect. We can now instantiate our enemy by using the instantiate method that lives in the monoBehavior class. Instantiate an enemy prefab at the enemy local position. And for the rotation, we can say quaternion.identity for now. Perfect. Let's create this enemy and set it as a child of the enemy group. So let's just pass the transform of the enemy group in the method. Perfect. Now we should create the enemies when we start the game. So let's try it out. Let's go back to Unity. Let's drag the enemy prefab right here so we can lock the inspector as usual. go to the prefabs folder, drag and drop the enemy into our field. Maybe we can create 10 enemies for now. Okay, cool. And regarding the radius and the angle, we can grab this data from the player game object. So let's unlock the inspector. Let's go to the crowd system, copy this angle, and store this radius in your memory. Okay. Now we can paste the angle right here and paste the radius from our memory. Cool. Let's hit play. And nothing happens, of course. Why? It's because all of the enemies have been created at the same spots as our runners. You can check that by selecting the enemy group, moving it forward, and you can see that the enemies have actually been created. But one issue here is that when setting the search radius and the move speed values for the enemy, we did not set them for the prefab. So they weren't saved. So let's hit play again, select our enemy prefab, and set the search radius to 5 and the move speed to 10, as we did before. We can also increase the search radius for them to run a little bit earlier towards the runners. Okay, perfect. So now let's try and move our enemy group on the z-axis, maybe to 20 on the z-axis. Let's hit play. And you can see that we have an issue here. Although we move the enemy group on the z-axis, the enemies were created on top of our runners. So let's fix this issue now. Okay, so for that, let's open our enemy group class. When setting the local position here, we are actually setting the world position because we are using the instantiate method. So there is a quick method to transform the local position to world position and vice versa. And this is what we are going to use now. So let's say vector3 enemy world position will be equals to transform point enemy local position. This will convert the local position of the enemy to a world position. So we can now use this in our instantiate method. Let's go back to Unity and check that out. Perfect. It's working, guys. Now let's hit play and see if all the enemies run towards the runners. All right, nice. But there is an issue there. We had 0 runners and we did not die. So we need to implement a game over state or game over panel to our game. And this is exactly what we are going to do in the next session, so stay tuned. Hello! In this session, let's see how we can add our brand new enemy group to a chunk. So for that, we are going to open the prefabs folder and open the chunks folder. Perfect. Let's now select our medium chunk and duplicate it by pressing Ctrl D. And let's call it medium chunk enemies. Let's say maybe 20 because the group will have 20 enemies. Cool. Before opening it, let's drag our enemy group and drop it in the prefabs folder. That way we can use it anywhere we want. So let's open our chunk now, double click it. Perfect, here it is. And now we can go back to our prefabs folder, drag the enemy group and drop it in the hierarchy. Cool. Where is it? Here it is. Let's set the Z position to 0 for it to be at the center of the chunk. And let's change the amount of enemies to 20. Perfect. Now we can go back to our scene right there, select the chunk manager, select the level 0, 0, and change one of these chunks to the chunk we've just created. So let's select any one of these, drag the medium chunk enemies 20 to the position 1, let's say, and hit play. Now you can see that 20 enemies have been created in our level. Perfect, let's hit play and we should have 0 runners. Cool, it's working. Before adding the game over, we can add a little bubble above the enemy group again, like we've done for the runners, so that we can have an idea of how many enemies are in that group. So let's do that right away. For that, let's open the prefabs folder, drag our enemy group into the scene, like so. Cool. Let's set the Z position to 0 because we want to duplicate our bubble that we've used for our crowd. So let's duplicate it, drag it and drop it onto the enemy group. Maybe we can rename it to bubble, simply. The crowd counter text is the same one, but the runner's parent will be the enemy group. But same issue as we've encountered for the player. We need to create an enemy parent right here. So let's create an empty game object and call it enemies, maybe just enemies actually. Select the bubble and drag the enemies game object onto the runner's parent right here. Perfect. Now we need to change our enemy group script a bit to specify that we want to create the enemies under the enemies game object. Okay, let's double click it. Let's create a new field for the enemy's parent. So let's make it serialized, private, transform, enemy's parent. Perfect. Let's copy that field and paste it right here in the instantiate method. You can also replace this transform right here by enemy's parent, but this doesn't change anything because the enemy's parent have the same position as our enemy group and the same rotation, all along with the same scale. Okay, so now let's select the enemy group, drag the enemy's game object onto our new field right here, and that's it. We can now apply these changes to the enemy group prefab by clicking overrides and applying all the changes. Perfect. You can check if the changes have been applied to the chunk we've created by going to the prefabs folder, chunks, medium chunk enemies 20, select the enemy group here, and check if the enemy's game object have been created, and it has, along with the bubble. Perfect. Let's hit play. And you can see that now there is a bubble above the enemy group that's telling us that there are 20 enemies. Cool. You can change this value now by maybe saying like we only want 6 enemies in our group. Hit play. And you can see that it has changed here again. Perfect. But when there is 0 enemies, the bubble is still there. So let's change that. For that, you can open the crowd counter class, and in the update method, we want to constantly check if the runner's parent has no more children. So either we don't have any enemies or we don't have any runners. And if that's the case, just destroy the bubble or hide it. It's your choice. So we can say if runner's parent dot child count is less or equals to 0, then we can just destroy game object. Perfect. Let's go back to Unity. Hit play. And now when fighting all the enemies, the bubble should disappear. And that's what happens. Cool. Awesome, guys. Now that we've done this, we can finally add our game over panel and the level complete panel. So we are gonna do one of these in the next session, so stay tuned.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.